Hey everybody, we're going to go ahead and get started, and we'll start with a refresh your understanding, thinking back to DPO and RLHF. All right, why don't you turn to someone near you and see if you got the same answer, particularly for the third and fourth one, but all right, so let's come back together. The first one is true. The DPO model does assume that we have a particular model of how people are responding to preferences, in particular the Bradley-Terry model. The second one is also true, even though we've been thinking a lot about when we actually have preferences. We can also use this in cases where someone just directly provided you with reward labels. And so RLHF as a paradigm is totally compatible with the idea of just getting rewards from some way. But normally when we think about that human feedback, it's normally from preferences. The third one is an interesting one. Does somebody want to argue why they think that is not a good way to learn about the reward model for board games?
There's multiple optimal points in the reward.
Yeah, you feel like there's like multiple options? Yeah, I think that could be one. I was thinking of something even simpler. Does anybody else want to add why you might not want to do this for board games?
It might be really hard to compare like states in like a game like chess, where the reward is one at the end, and like self-play might just.
Yeah, so it might just, and also because we normally know what the reward model actually is in games, and so like if we know that at the very end we can say this is a +1 or this is a -1, there is no reason necessarily to assume we want to look at like two game states and ask a human to try to judge which of those two is better. We know the ground truth reward, and so it's probably better just to directly use those. And it may be that those sort of pairwise rankings for intermediate game states might not be very reliable too. And then the last one is also true. DPO and RLHF can both be used in extremely large, with extremely large policy networks. All right, so where are we? Last time we talked a lot about Monte Carlo tree search, and we talked about AlphaZero. And what we'll do today is we'll talk briefly to kind of finish up that part, just quite briefly. I want to clarify a couple things that I mentioned last time. So the rest of the day we're going to have a guest lecture, almost the rest of the day, we're going to have a guest lecture by Dan Weber, which is a way to sort of introduce the last part of our course, which is to think about where the rewards come from in terms of how we make judgments about which rewards we might want to prefer or not. And we'll talk about that today, and we'll talk about that after the quiz as well. But before we do that, I just want to do a little bit more on Monte Carlo tree search. So let's see if we can get take 2 for the video first. So I think that sort of captures, it's a nice, we don't normally get documentaries made about the work that happens in artificial intelligence, at least not yet. But I think that it's a pretty powerful example of why people were so excited about this result, and sort of the implications it had when you can exceed the best performance in the world at something by computers. And we've seen examples of this in the past. For those of you who heard about it, there was an IBM Watson for Jeopardy case a number of years ago, and I remember being in the audience when that was happening. Many people watched it in different watching parties at the time, and I was in one of those watching parties, and it was a similar moment in AI of sort of thinking about what are the levels that we're going to be able to achieve in AI, and what are the implications of that for sort of human expertise and human excellence. So Monte Carlo tree search, of course, they did win the game. DeepMind did win against Lisa et al. Let's now just go back and sort of think a bit about what Monte Carlo tree search and AlphaZero are doing. So this is another refresher understanding, and I'm also doing 2 of these today just to give you an example. These are the types of questions you also might see on the quiz. So we'll do another one of these, and then I'm going to clarify a couple points about AlphaZero from last time. Why don't you find somebody near you and compare your answers? Okay, good. I'm hearing a lot of discussion about this, which is good. So the first one is true. The first one is it does approximate a forward search tree. Okay. The second one is false, and I know this is a little bit subtle. So Monte Carlo tree search tries to approximate the forward search tree, but as you might remember, the forward search tree can scale exponentially with the number of states and the number of actions, because you're expanding by both of those at each level. And so what Monte Carlo tree search does is it uses its dynamics model to sample a next state. So you don't have to enumerate all the possible next states. So it uses sampling to help with the state branching factor, but it doesn't tell you what to do about the action fraction factor. One thing you can do is you can do upper confidence trees, and then that tells you how to use a bandit to figure out, which action to select next. in AlphaZero, we see that even that is likely not to be sufficient when you have an enormous branching factor, and so you may need some sort of additional weight, like the probability, like a policy, to select among those actions. The third one is also false. So this was true in the original AlphaGo, and I think in the Lee Sedol one too that you saw in the video. They did have two networks, but in AlphaZero, they just have a single network, and it outputs both a policy and a value. So it just has two output heads. The third thing is true. So kind of amazingly, even if you spend 40 days and you've got many TPUs, et cetera, to learn a policy output and a value output in the network, they still do at test time, like if you're playing Lee Sedol, they still do additional guided Monte Carlo tree search at that point, and it makes a big difference. So I think it was something like going from like an ELO score of like 3,000 to a 4,500 or 5,000. I'm gonna get the numbers wrong, but it was a huge gain by doing a little bit more of extra local computation. And the fourth thing is also, or I guess the next thing is also true, which is self-play does provide sort of a form of implicit curriculum learning, because the agent is always essentially working with an opponent that's very similar to its level. In fact, it's itself, so it's exactly at its level. And that means that sort of the density of reward it gets is gonna be much higher than it would get if it was playing an opponent that was much higher or much lower. Okay. The other thing that I wanted to clarify is, so when we talked before, we talked about selecting a move in a single game, and we talked about how it both maintains this it maintains a QSA for sort of a certain node, as well as this upper bound here, which is going to be proportional to this policy function it gets from the neural network, divided by 1 plus the number of samples. So I mentioned in class, I just wanted to make sure to clarify this. I mentioned in class that I thought that all of the S's here are just the nodes. But S is a little bit weird of a notation because you could imagine it could either be the state space or the node, like that part of the tree search. I look back on it, this is actually the node. So I was correct in what I said last time, but I just wanted to make sure that was clear. So they're thinking of sort of each of these points as being like a particular SA. But in theory, and again, I'm not a Go expert, so I'm not sure how often this happens, you could end up at the same sort of game state lower down in the tree, and you would maintain totally different statistics for down there. So you're not sharing across those. And there's just, simplicity to do that in terms of, there's simplicity that can help in terms of the architectures that you need to derive and just sort of simplify some of the storage for this. So it is, these are per node. And then the other thing that I just wanted to clarify also is that when you get to the root later and you're making a decision over which of these actions to take, I mentioned that what they do at the final end is that they're going to do something proportional to an SA at the root divided by 1 over tau. So this is going to be the policy at the root. I just wanted to make sure to be clear about what that does. So this is sort of prioritizing parts of actions that you've taken more, that you've explored more in your neural network. So let's just see a little bit about what this would look like. So if tau is equal to 1, what that would mean is that your probability of taking action A from the root would be equal to the number of times you've taken action A in the root divided by the sum of the times you've taken, well, just really the total number of rollouts you've done from the root. So that would be strictly proportional in that case. If you have a tau less than 1, that means that you are going to upweigh some of these things. So then you would have, so let's say if tau is equal to 0.5, then you would have NA root squared divided by the sum of NA root squared. I'll put A prime there. So what that would mean is that if you make tau go closer and closer to 0, then this is basically going to do a winners takes all approach, and you'll basically select whichever action you took most from the root. And then as you go to more towards 1, it's sort of equally spread across all the times you've taken each of the actions. And as you might imagine, that's going to have different implications for sort of how exploratory you are. Now note that none of these things are doing it based on what the value is at the root. All of these are just based on essentially how much of the time you've explored different parts of the tree. So I just wanted to make sure to clarify those in those cases. Does anybody have any other questions about AlphaZero? And I do just want to say that as I mentioned before, there's a number of different other derivatives that have happened since this. So there's MuZero, which doesn't even need to know the rules of the game. And there are also a lot of sort of sophisticated approaches which have to do with hidden information, games like poker. So in this case, there's full information. You know exactly where all the white stones are, you know exactly where all the black stones are. There's no hidden information that either player has, and there's only 2 players. But there's been a lot of work at thinking about cases like poker and others where there's some cards that one agent doesn't see from the other, and so then how do you play optimally in those games as well? So do you have any questions before we move on to our guest lecture? Yeah.
With these other models, like specifically MuZero that doesn't make the rules of the game, do we just observe that it, even though it doesn't know the rules, it like learns just as well, or does it do better without knowing the rules? Like, what's the consequences of doing that?
Yeah, that's a great question. I'd have to go back to the paper to remember the exact results. It certainly can do just as well. So it can quickly, you still have to give it some feedback. It has to know whether or not it won, but it doesn't have to know sort of all the individual rules. And so I just don't remember how much additional data you needed in that case. As you guys might remember from last time, we saw that there is a really substantial impact of architecture. So depending on the architectures you're using, and are you using a convolutional neural net or some other different types of networks, those also make a massive difference to the amount of data you need and the quality of the result. So I think that's something to keep in mind when we think of removing information like what the rules are. You could imagine that if you do that, but then you have some other innovations in terms of the architecture, it might be that you need only the same amount of data or even less than what were needed here. So generally, they don't do full ablations over all the combinatorics of the sort of ways these systems are specified. That's a good question. But that work certainly suggested, and they've also extended this to other games, so things like chess and others, just to show that you can use very similar techniques to conquer those games as well. All right, with that, let's switch over to Dan. So I'm really delighted to have Dan talking today. He is, I guess I'll keep this here until he comes up. He is a postdoc fellow here at Stanford. He'll introduce his own background a little bit more, but he has a lot of expertise in thinking about different frameworks for how do we think about rewards and what are the implications of the different ways we're going to define those in terms of the subsequent type of systems we might develop.
Please hold your applause until you see how it actually goes. All right, I need a sec to get this hooked up. While I do that, I should note I am gonna ask you at various points maybe to talk to some of the folks next to you. So if you're not in a good position to do that, now might be a time to move to get yourself in such a position. Okay, is that good? Is that too loud? Just right? Love it. What to do? Okay, and we go to 250. Yes? Yep, perfect. Or we can at any rate. Great. Okay. Yeah, I'm Dan Weber. Here today to talk to you about value alignment. But before we do that, maybe it is just worth saying a little bit about who is this guy? Why should we listen to him or care at all about what he has to say? He's not the professor. So as Emma mentioned, I am a postdoc here at Stanford in HAI and EIS. That's the Institute for Human-Centered Artificial Intelligence and the Center for Ethics and Society. If you've taken a lot of CS classes at Stanford, you've probably seen somebody who has my job at some point or other. Yeah, big part of my job is embedding ethics into computer science courses like this one. Before I came here to Stanford, I got my PhD in philosophy at the University of Pittsburgh, where I wrote my dissertation on moral theory, which basically means just trying really hard, maybe too hard, to think systematically about value, which is what brings me to you today. So before that even, I got my bachelor's in computer science at Amherst, did a couple of years in software development after that, so I'm not completely new to CS. I know this world a little bit. I did take an introductory course on AI. That was 10 years ago. I think the field has changed immensely since then. I don't even think we covered reinforcement learning at all. So you all are going to know the reinforcement learning way better than I do. I'm not here to be an expert about that. What I am hoping to do is give you a bit of a window into how to think about value and how it might be more complicated than you think. So we're not going to solve any deep problems about value in the next hour. We're not going to be able to go very in depth on a lot of this stuff. If you're interested in that, I recommend courses in the philosophy department. But just try to give you a quick, maybe lay of the land, sense of sort of the range of possibilities when we're talking about value and value alignment. Okay. Might help to start with an example of value alignment, or maybe more accurately, an example of value misalignment. One of the classic examples in this literature is paperclip AI. But this example from Nick Bostrom in 2016, maybe you're all used to this in reinforcement learning, but tells you something about the state of this literature that a classic example could be from 2016. So Bostrom describes an AI designed to manage production in a factory, which is given the final goal of maximizing the manufacture of paperclips. Does anyone have an idea maybe of how this example continues? Maybe you've seen it before. Anyone know this one? No? Okay. Well, in Bostrom's example, at least, this AI proceeds by first converting the Earth and then increasingly large chunks of the observable universe into paperclips. Okay. Now, Bostrom is thinking in particular about super intelligent AI. That's what his book is about. So he's got the destruction of the entire universe in view. But even a less powerful AI system might pursue a simple goal like this in surprising ways. Does anybody maybe have a more mundane example of what could go wrong if an AI system were, say, in charge of a paperclip factory, given no further instruction than to maximize the production of paperclips? Yeah.
Maybe schedule for people for a lot of shifts, like through the night, and then fire workers who come in and hire new ones.
Yeah, good, right. Yeah, we could maximize production if only we trapped people inside the building and made them work around the clock, right? Excellent. Any other, yeah?
This doesn't say anything about the quality of the paperclips, right? So they could all be really bad.
Good, yes, exactly. It might be that the easiest way to maximize the number of paperclips I produce is to produce really terrible paperclips, right? That's not really what I was looking for, probably. Great, thank you. Anyone else? Yeah.
I mean, if the price of like electricity changes like at different times of day, it could be like trying to make paperclips, but just like economically and efficiently.
Yeah, good, right. So it's maximize the number of paperclips, but there's no sense of sort of other goals that you might also want to pursue here, like efficiency or minimizing the amount of electricity you use or anything like that. Great, yeah, or you could imagine, I mean, depends what levers the AI has to pull, right? But you could imagine it recycling the factory's plumbing for raw materials, right? Or locking out humans who could interrupt its process, right? Something like that. So, great. So, in general, we might say the problem of value alignment is this problem of how do we design AI agents that will do what we really want them to do. Where what we really want is usually a lot more nuanced than what we say we want, right? Humans work with a lot of background assumptions, and these assumptions can be hard to formalize, easy to take for granted, right? If I told you, as the manager of the factory, to maximize the production of paperclips, you would realize that you should do that, consistent with existing labor laws, or that you should make paperclips that actually work, or that you should be on the lookout for keeping your costs down, things like that. But because these can be hard to formalize, they're easy for us to forget about, it's hard to solve this problem just by giving better instructions to AI agents. And here, I mean, if anybody wants to give it a try, what would be the better, how would you solve this problem maybe just by trying to give a better instruction to the AI? Anybody have what they think might be an improvement on just maximize paperclip production? Yeah.
Give like an example to batch.
Good, yeah, so yeah, specifying that you want paperclips of a certain quality and giving a sample of what that looks like. Good, that would help, that could help address this problem potentially of can you maximize production just by making worse paperclips, right? Might not go far enough to say, and by the way, you shouldn't work the factory workers around the clock, but great start, yeah.
Maximize the long-run profits of the paperclip factory.
Good, good. So yeah, giving a broader goal, right, I want to maximize the production of paperclips, but that's something I want probably because I want to maximize the profit that the factory generates. Good. Is that going to be enough to avoid all of the problems that we've seen come up? I mean, yeah.
I mean, it's most of them, right? Like, you need high quality paper clips. You can't turn the universe into paper clips. Your profit will be zero. You can't be using too much electricity or like cotton, like doing things economically and efficiently because it won't be profitable. I mean, the labor laws are probably the thing that you'd be violating.
Yeah, right. I mean, if there's enough people, willing to work in this factory, maybe we're able to keep a lid on how poorly we treat people. We could get away with maximizing profit while still. But good. Okay, so that's getting us some of the way there. But still, there's a worry about about essentially treating people well. Okay, so. I mean, we could keep doing this all day, but hopefully this is a little bit of an illustration. Even trying to think of better instructions, you might just realize, oh, there's another thing I forgot. There's another thing I forgot. I mean, you can compare this maybe to the difficulty in manually specifying reward functions. I mean, in some sense, this is the same problem, right? Okay, I think I know what the thing is that I want. Okay, it turns out to be much more complicated than that, much harder to specify. Especially when you're thinking about making a system that's going to take instructions from users, maybe who are not experts in reinforcement learning, right? Folks in this room are going to be relatively good at foreseeing these kinds of problems with giving incomplete instructions. If you're designing a system that's supposed to take instructions from non-expert users, they might not be so good at foreseeing these issues. Okay. Maybe I should say any questions now, and in general going forward. I mean, if anybody has any questions at any time, don't hesitate to raise your hand. Okay. So we have this problem. How do we design AI agents that will do what we really want? But that's a little underspecified, right? I mean, there are lots of things that we might mean by a phrase like what we really want. So here's one of them. You might think value alignment is the problem of designing AI agents that do what we really intend for them to do, right? The problem with paperclip AI might be that it failed to derive the user's true intention, right, which is to, let's say, maximize production subject to certain constraints, right? Maximize production without overworking the workers and, while making sufficiently good paper clips and while keeping costs down and so on and so on and so on. Deriving that nuanced, complicated intention from the underspecified instruction, maximize production, right? If that's how we think about value alignment, then of course the solution is going to be to design AI systems successfully do this translation, take underspecified instructions, figure out what the user's actual intention is that they're trying to express, and then act on that instead. How is this from a technical perspective? Here's Jason Gabriel, a researcher in philosophy and ethics of AI. So what he says about it, he says, this is a significant challenge, and he means from a technical perspective. To really grasp the intention behind instructions, AI may require a complete model of human language and interaction, including an understanding of the culture, institutions, and practices that allow people to understand the implied meaning of terms. That's what he said in 2020. How do folks in this room feel about how this quote has aged maybe in the last 4 years? Does this seem like a significant technical challenge? Does it seem less significant maybe than it might have seemed 4 years ago for any reasons? I'm seeing a shaking head. Why not?
Well, you're probably trying to imply, trying to allude to GPT, but I don't think that's enough because GPT might like omit certain aspects of the world model that might still cause loopholes like that. So I don't think the problem has really been solved.
Good. Yeah. So yes, I am not a subtle man. I was indeed thinking. Yeah, require a complete model of human language and interaction. That maybe sounds like a model that a lot of folks have been hard at work developing. But yes, I agree with you. So you might think, could you use something like an LLM to affect this translation as part of the system? How complete do we think those models really are? If I give this if I say, if I give to ChatGPT, the user wants to maximize production in the paperclip factory, what do you think they really intend? Is it going to catch all of the nuances that are typically communicated, when one human is talking to another? I agree. There's reason to doubt that. See what the future holds. But that's the technical challenge. There's a philosophical challenge here as well, which is that you might think our intentions don't always track what it is that we really want. So classic cases of this might be cases of incomplete information or imperfect rationality. We've sort of already broached this one, right? I mean, suppose that I intend for the AI to maximize paperclip production, again, subject to these constraints, because what I want is to maximize return on my investment in the factory, right? If the AI knows that I would get a better return by producing something else or by selling the factory, has it given me what I really want if it does what I intend, which is for it to maximize paperclip production? Right? Well, in one sense, yes, but in another sense, no. You might think that other sense is the more important one. It's not giving me the thing that I really wanted because that thing is coming apart from my plan about how to get it. Okay. So you might think the solution here is that what you really want is an AI agent that does what the user prefers, what they actually prefer, even if this isn't what they intend. On this interpretation of the problem, paperclip AI is misaligned because I prefer that it not destroy the world, or I prefer that it not lock all the users in the factory, all the workers. Okay. Now, the problem here is that if you want to align to what the user actually prefers, there's going to have to be some way for the agent to know what the user prefers when that differs from the intentions that the user expresses. How are you going to go about doing that? The solution to this might be to work with the user's revealed preferences, right? Preferences that are learned from observing the user's behavior or feedback. Obviously, you've learned some techniques for how to do this kind of thing, but not every technique is going to be like this, right? You're going to have to do something like inverse reinforcement learning or reinforcement learning from human feedback that allows the agent to train on observation of the user to try to determine what they prefer based on how they've behaved or what they've told it its preferences are. Of course, you're going to run into this problem that from a finite number of observations of the user's behavior or preferences, there are, at least in theory, infinitely many sort of preference functions that could represent. Inferring that could be a challenge. And it might be especially hard to infer preferences about unexpected situations, like emergencies, where you don't have any you're unlikely to have directly observed the user's preferences about unusual emergency situations because they arise so rarely. But you might think it's precisely in unusual or emergency situations where it's so important for an AI agent to be aligned to our values. So those are some of the technical challenges. But here again, we have a philosophical problem, which is that just as my intentions can diverge from my preferences, it seems like my preferences can diverge from what's actually good for me, or so some people might think. So, for instance, a lot of people prefer to smoke, but you might think it's not really good for them to do that. Or I might prefer to maximize profit on my paperclip factory at all costs, but maybe it would be better for me to be less focused on money and spend more time with my family, right? The thought here is that your preferences might actually, in some cases, come apart from what's really in your best interests, objectively speaking. And that this is something that you might try to align an AI agent to instead. We want to do what's actually in the user's interests, even when that's not what the user themselves prefers to do. Right? If you think this, you're going to think paperclip AI is misaligned because it's objectively bad for me for the world to be destroyed, or objectively bad for me for these things to, for the pipes in my factory to be ripped out or what have you. Here we face sort of a combined technical and philosophical problem, though, which is that unlike the intended meaning of my instructions or my revealed preferences, what's objectively good for me is not something that can be determined empirically, right? This is a philosophical question, not a scientific one. So it's not just a matter of building the right model of human language or observing the user enough to figure out what's actually in my best interest is not entirely an empirical endeavor. You've got to actually do some substantive moral philosophy to solve this. Now, the bad news for solving this problem is that there's a lot of disagreement about what is objectively good for a person. I say philosophers disagree about this, but I think non-philosophers also disagree about this as well. Right? Is it just a person's own pleasure or happiness that's good for them? Or is it the satisfaction of that person's desires or preferences? That could be different from pleasure or happiness. I might have preferences that will be satisfied only after I'm dead or something. I'll never derive any pleasure from their satisfaction, although they could still be satisfied. Or do we want to say that things like health or safety, knowledge, human relationships, these things are objectively good for us even if we don't enjoy them, don't prefer them? These are all sort of live options in the theory of value, and depending on how you answer this question, you're going to be looking at a different kind of value, even if you already know that what you want to do is align to what's in the user's best interest. Okay. The good news, though, is that behind this disagreement, there is quite a lot of agreement, I would say. These things like health, safety, liberty, knowledge, dignity, happiness, almost everyone agrees that these things are at least usually good for the person who has them, even if you think that really ultimately all that matters, all that's good for a person is their own happiness. Well, these things typically make the person who has them happy. You might think you don't really need to resolve this underlying philosophical dispute to have a good sense of what's in the user's best interest, right? I mean, these are things that for the most part are in a person's best interest, sort of no matter what theory you endorse behind it. Okay, any questions about any of that so far? Okay. One complication about aligning to the user's best interest is that one thing that we normally take to be good for a person is autonomy, right? Which is the ability to choose for yourself how to live your life. Even if you don't always make the best choice, it might be good for you to have this kind of control over your own life, right? We want to avoid paternalism. We want to avoid choosing what we think is best for someone rather than letting them choose for themselves. So even in a case where you're aligning to the user's own best interest, you might still need to take their intentions or their preferences into account. It might be that part of what's best for them is to have their own intentions fulfilled, to have their own preferences honored. Okay. So this has all been pretty abstract. I want to move into a slightly more concrete case study, but first maybe just to recap what we've covered so far. Value alignment is this problem of designing AI agents to do what we really want them to do. But this could mean a lot of things. It could mean doing what we really intend them to do, what we really prefer that they do, what it would be actually in our best interest for them to do. And all of these things can come apart. They're not necessarily the same thing. And they might impose certain technical or philosophical constraints on your approach. Okay, let's talk about how this works, or what kind of difference this could make in practice. Think a little bit about LLM chatbots. So everyone who talks to ChatGPT is talking to the same chatbot. Okay, there's different, there's GPT 3.5, there's GPT 4. Ignore that, right? I mean, fundamentally it's the same chatbot for everyone. But plenty of chatbot providers are now offering a wide range of different chatbots with different personas. Some of these designed by users themselves. So these examples are all from Character.ai, which promises personalized AI for every moment of your day. So here this comes out maybe a little small, but you can talk to the creative writing helper. You can talk to the Are You Feeling Okay bot. You can talk to the dating coach. These are some of the relatively normal ones. You can talk to depressed roommates. You can talk to Torybot. I am Torybot. I believe in the free market. You can chat with AOC. You can chat with Donald Trump. You can chat with Feminist Faye. I am a feminist that hates Donald Trump. Okay, lots of variety, lots of options here. You could imagine yet stranger and stranger personas that you might build into a chatbot. So, or that your users might, right? None of this, all of these are designed by users. None of these are coming top down from the provider of the LLM. So, okay, so I want to think about this a little bit. Imagine you're building an LLM chatbot to serve as a source of news for users. I mean, maybe this is going to strike you already as crazy, but I think there are a lot of people out there who already treat Google as their primary source of news. A lot of people who are replacing Google and other search engines with LLMs. So I think there's demand for this. Imagine you were wanting to fill it. Think a little bit about these questions. In what ways would you make the chatbot personalizable if you were interested in aligning to the user's preferences? Right? In what ways might you make it personalizable if you wanted to align to the user's best interests? And think a little bit about the pros and cons of this. So I think take a minute to think about this, and then maybe chat with somebody near you, compare notes, see what you're thinking, and we'll come back in a couple minutes for a larger discussion. All right, I've been hearing a lot of good conversations that I'm not eager to cut short, but maybe they're conversations that we can now bring back to the whole room. So anybody have any thoughts from their discussions that maybe they want to share? I know some of you have thoughts because I was hearing a lot of good ones out there. So don't be shy. You probably have better thoughts than I do. If you don't say anything, then I'm just going to tell you what I think, and then you're going to be stuck with that. Yeah.
I guess for the first point, it would be, I think it's pretty simple. You'd use sort of a preference optimization approach, and you'd offer 10 different questions of hey, do you prefer this answer or that answer? And then you would optimize the news that's being fed to that user accordingly.
Yeah, good. If like you say, fairly simple. If I want to align to the user's preferences, I'm going to figure out what it is that the user prefers. I'm going to give them news that fits that profile, right? Is that sort of what everybody was thinking about this first question? Anybody have something they want to add to that? Yeah, great. Okay, I think that's exactly right. Okay, what about if you were trying to align to the user's best interests, their own good, objectively considered? Yeah.
I have a thought on that one, which is that it's pretty hard to know what someone's best interest is, as well as avoiding sort of the tenet that was on the previous slide of don't be paternalistic.
Right.
So really the only way you could have any hope of doing this would be optimizing for best interests of like an entire population. So you basically, like, if it doesn't apply, if the policy of best interest doesn't apply to everyone, then I would argue that you can't actually do it for an individual user. So that's the way you would personalize it if it's wanted to align to a user's best interest. Is you wouldn't ask that question to begin with. You would just have it set already for the entire population.
Okay. Yeah. I mean, good. I think. I need to constantly resist the temptation to just turn every one of these lectures into a philosophy class. So I love that answer. I'm curious about I'm curious about why it might be less difficult to determine what would be in the objective best interest of a large group than maybe of one person. But this is a question we'll come back to maybe later. Anybody else have thoughts about this second one? Something different come out of your discussions? Yeah.
Just take the movie Her as an example, right? You got to know the person very well. The person opened up a lot of data, a lot of the information. Then you will be able to maybe prioritize on how you make the suggestion, and also depend on the person using the tool, right? For example, some tools are better on delving into the news, trying to understand the sources. Some of them are better at you just want to take the most important thing and then just you don't have to spend time on an email, on random news and all that. So I'm talking about like two components at least. One is the person better. The other thing is the behavior and how they would use the tools, and just refrain. I mean, the tool should be refrained from like extending too much and just grabbing too much attention of the user.
Yeah.
Balancing that up.
Good, thank you. Yeah, and I think that there is something to this, right? That like, it might be that just from observing someone's preferences for long enough, getting that much data about them, you might be able to get a little bit of insight, maybe into sort of what's in their best interests, even when that diverges from what they want in the moment. So, yeah, great. I see. Yeah.
We similarly had an idea about like maintaining some sort of state for the users, like best interest. Like maybe you could have like some sort of structure that would represent different aspects of the best interest, which could be personalizable to the user. And with every like LLM interaction, it would re-prompt the LLM and then change this if appropriate. And every time you are trying to get output for the user, you could put this as part of the context and write the prompt accordingly alongside whatever the user is asking in order to fit that goal better.
Good. Well, that sounds to me a little bit more like maybe aligning to the user's preferences. Maybe I misunderstood. This sounds like kind of trying to figure out what it is that the user wants to get, what they're looking to sort of get out of the bot, and then determining what to return based on that. Maybe I misunderstood.
I don't think that's necessarily true. I think you could write a prompt that would, like the internal prompt for keeping up the state of the user's best interest could be written such that, and the fields could be provided such that it would try to you could ask it to meta reason about what the user's interests likely are based on.
Oh, I see. Okay, good. Yeah, great. Yeah, anybody else? I mean, maybe there's in some sense maybe a more basic question behind this, which would be something like what is maybe in a news-seeking agent's best interest? What kind of news would it be best to provide somebody? Yeah.
Probably news that shows like a variety of perspectives, and you check that it's actually correct as well. I think it's in the user's best interests that they're properly informed, as opposed to maybe like only seeing news that puts them in a good mood or aligned with their existing opinions.
Yeah, good, right. Yeah, you might think, in contrast to the approach we discussed earlier of we're gonna query the user about their preferences every time that we give them news. We're gonna say, did you like that? Was that what you were looking for? Yes, no. We're gonna adjust and give you the news you want based on that. You might think it's actually better for people to be exposed to high quality news, unbiased news, to be exposed to a variety of opinions and arguments, rather than, right, what's the worry about aligning too heavily to the user's preferences is that you might be putting them in a kind of echo chamber, right, where they're getting all of their news from talking to Donald Trump bot or talking to feminist bot, and they're not getting other perspectives. Yeah, good. Does anybody else have a different answer to that question maybe? What would sort of be in the user's best interest to receive as news, or how you would approach that from like a design perspective? Okay. Well, good. I think that's definitely right. I mean, in terms of pros and cons, does anybody have sort of get into this? Like, which, if you were designing the news chatbot, which of these approaches would be better? What would be the pros of one, cons of another? Yeah.
I mean, I think like optimizing for best interest is almost like paternalistic, because you're assuming that you know the best interest of the user, or you have a good approximation. You might really not know at all. So it's like if that user had like some sort of tragedy or whatever in their life recently, and then like there's some sort of recent news event has like a lot of mass death. Like maybe they don't want to be exposed to that, even though maybe it's like a very important event, you should know about this. But like you don't have complete state of like the user's psychic state. Like how they actually feel. So maybe just using the preferences that you actually have, like just from using the app, what did they click on, might be better.
Good. Yeah. So there's, I think that's great. So there are like, even if we can say things maybe at a very general level about what is in a person's interest, right? What is actually good for a person in general, right? That leaves a lot of room for variation from person to person, right? Especially if you think that quite a lot of what's good for a person is built out of sort of subjective interests of theirs, right? Or their desires, or what makes them happy, what makes them unhappy. That's not a thing you might have full access to. So there is this problem that if you're trying to align to what's really good for the user, your only real way to do that is by aligning to what it is that you think is good for the user, right? And you might be good at figuring that out, you might not be. And absolutely that's where you run this risk of paternalism. So an advantage of just aligning the user's preferences, giving them what they've said that they want, means that you avoid that risk, right? You avoid trying to position yourself as saying, no, I know what's really good for you, when maybe you're not in a position to determine that. Yeah. Anyone else on this point? Okay. No?
Yeah. I just thought that the counter argument is that, running the risk of being paternalistic, you actually give convenience, but then giving them low quality choices, you actually waste them a lot of time. So, apps evolve. Yeah.
Yeah, I think that's right. And right, I mean, to the earlier point, it's, there might be some aspects of the user's best interest that are easier to determine than others, right? It might, we might be reasonably confident that it would be in any user's best interest to be given high quality sources of news, to be exposed to a variety of opinions. That might be, you might want to align in part to that sort of general human interest while still allowing some room to align to the user's preferences. So these are not necessarily mutually exclusive goals in alignment, right? I mean, it might be, in some ways it might be worth focusing more on the user's preferences. In some ways, in some cases, contexts, you might want to focus more on what do we think is actually good for the user, because what they prefer might be, junk information or convenient bias confirming information, things like that. Okay, great. Well, there's one thing I think that has been not completely absent maybe from our discussion, but I hope noticeably absent from my lecture and from my slides so far. Is there maybe a big piece of the puzzle that we're missing, something that you would have thought, this is what we're going to talk about with value alignment, and why haven't we gotten there yet? Anybody at all? We've talked about aligning to the user's intentions. We've talked about aligning to the user's preferences, to the user's best interests. Yeah.
Like a way to measure alignment?
A weighted measure alignment, yes, that has been absent. I just think, yeah.
Maybe aligning to a society's overall interests rather than just a person.
Yeah, so you are correct. But I was thinking, yeah, I mean, that there are people other than the user. Where's my text? There's my text. Yeah, there are other people whose interests are important, maybe, to take into account than just the person who is giving instructions to the agent. So you might think there's really another possible interpretation of what we're after with value alignment, right? Which is that an AI agent is value aligned if it does what's morally right, right? I mean, the main problem with paperclip AI isn't that it does what's bad for me, it does what's bad for everyone if it destroys the world, right? Or it does what's bad for the factory workers if it makes them work around the clock making paperclips, and so on, right? So earlier we were sort of focusing on what do we mean by what we really want? What does really want mean? This would be to focus a little bit more on the we. What is it that we really want? Because of course what the user intends, prefers, even what's in their individual interests might be bad for others, right? We probably don't want to say that paperclip AI is value aligned if it maximizes production by, exploiting the workers in the factory, even if I, as the user, have no qualms about exploiting the workers, right? Okay. That said, it wasn't a waste of time to start by focusing on the user, right? Even if we want to align to morality or to the interests of more people than the user, we also do want to align to what the user wants when what the user wants is morally acceptable, right? So it still matters how we understand what it is that the user really wants, even if we need to place that in a larger moral or societal context. But of course, here too, we have a philosophical problem, right? I mean, which things are really morally right? There's a lot of disagreement on this one too, not unlike the question of what is objectively good for a person, right? Is it right to lie to spare someone's feelings? Is it right to pirate copyrighted material? Right? Is it right to buy luxuries when you could donate to charity instead? Is it right to kill one person to save 5, or 1,000, or 1,000,000? Right? These are, at least some of them, I hope you think, difficult moral questions. Certainly they are moral questions that people disagree about. Again, philosophers and non-philosophers alike. So how do we align to what's morally right in the face of this disagreement? This is, you might think, where my field of study comes in. You might turn to moral theory, which is basically just a systematic attempt to answer questions like these, right? So a moral theory you might have heard of, it's called consequentialism, says that an act is right if it produces the greatest net good of any act available. Or you might have heard of utilitarianism, which is a kind of consequentialism, says that you should produce the greatest total happiness that you can across all people. Right? If you have a theory like this can be used to answer some of these difficult questions people disagree about, right? Is it right to lie to spare someone's feelings? Well, if you're the consequentialist, you'll say it might be, if you can get away with it. If no one discovers that it's a lie, and it makes somebody feel better, that might produce more good than not telling the lie. So there's an idea here, which is that we could align AI to morality, to what's morally right, if we align agents to the correct or best moral theory. There's going to be a philosophical problem with this. Does anybody think they know what it's going to be? Has a similar form to all of the philosophical problems we've encountered so far. Well, there's a lot of disagreement about what the correct moral theory is. So there's disagreement not only at the order of sort of ground level moral facts about whether you should tell a lie to spare someone's feelings, but also about the best theory for systematizing this kind of stuff. Right? We already saw consequentialism, but there's a whole host of others, and just to put a few of these on the table, just to give you a sense of the range that we're looking at. You could be a prioritarian, and where you would think that really what you want to do is not to maximize the total good, but to produce the greatest weighted sum of good, where the interests of those who are worse off is given more weight. Or you could take this to a sort of extreme, a kind of maximin or minimax view, where what's morally right is to make things as good as possible for the person who's left the worst off by what you've done, or to minimize the negative consequences for the person who suffers the most. So in cases where you have to think about a quantifiable good, but if I have 4 people who I can, how would I do this? Assign goods to, I have the option to say, I have options to distribute goods, say, these ways among different people. Right? If I'm the consequentialist, I'm going to say, well, I want the one that produces the most total good. That's this first option. If I'm a prioritarian, well, I'm going to need some kind of way of weighting this. Say that, the way to give more weight to the people who's worst off is that we weight the good to you on a log scale or something. Right? Then in base 10 or at least this is going to be the prioritarian's choice, right? We want to, by giving more priority to those who have it worse, sorry, I'm not explaining this very well, trying to move too quickly. If I was taking the log of each of these as the prioritarian, I'd say here, we have, this is coming out to 6, this is coming out to 7, that's better. If I want to make things as good as possible for the person who ends up worst off, I might choose this last option, even though in this option, we're getting the least total good, right? The person who ends up worst off is doing better than the person who ends up worst off in the other options. So all these options and more are available to you in moral theory. Right? You might take a satisficing version of any of these views. Instead of trying to maximize the total good, you might think an act is right if it just produces a sufficiently great sum of good or weighted sum of good. We haven't even yet touched deontological views, which hold that even acts with the best consequences can be wrong if they violate certain moral rules or rights. Often these rules will be rules like don't murder anyone, don't steal, don't lie, keep your promises. Right? You might think that an act can't be right if it involves stealing from someone, even if it produces a lot of good. This is something that a view like consequentialism might not capture. Right? Although you might think that these rules or rights are themselves justified by their good consequences. It would be best if we accepted rules like this and followed them. Okay. Returning to this problem of paternalism that we encountered earlier, there is another problem here. So one is there's just, what is the best moral theory? Who knows? That's, I've been working on that for a decade and haven't gotten much closer to it. But even if we knew what the best moral theory was, it might be bad to design AI agents to act on moral values that their users don't share, right? This could be because we want to avoid a kind of paternalism where we say, no, these are the correct moral values. Could be for more practical reasons, just the users won't trust AI agents if they disagree with them about moral matters. Okay, so there's some difficulty trying to align to the best or the correct moral theory. But also like with the objective good, where there's a lot of disagreement here, there's also quite a lot of agreement about what is the morally right thing to do. Right, in simple cases, we all agree. You shouldn't kill people. You shouldn't lie to them. You shouldn't steal from them. So another idea for aligning to morality would just be aligning AI agents to what we might call common sense or consensus morality, right? Common sense moral ideas that most people agree on. Instead of trying to make AI morally perfect, we should just aim to have it make moral decisions like a normal person would. Right, this view probably ends up being pretty deontological and satisficing, right? Most of us think you follow certain moral rules, you respect other people's rights, then you're not morally required to do the best you can. It's fine to do less, to prioritize yourself in some cases, things like that. Right, now one advantage of aligning to something like common sense morality rather than to a particular moral theory is that moral theories often have surprising implications. I know we're just about out of time, so I'll skip to the chase on these. I mean, you can think about the consequentialist requirement to maximize net good. I mean, suppose you had an AI agent that was a surgeon, five patients dying, each of which needs a different organ transplant to save their life. Well, if you're thinking about just maximizing the net good subject to no constraints, maybe what you think is, well, that nurse walking by in the hall has all of the organs that I need. Maybe if I just harvest the organs from the nurse, put them in the 5 people, save 5 lives at the cost of 1, 5 is greater than 1, we just maximize the net good. That's probably not what you wanted your surgeon AI to do. Think about cases where you might want to break a deontological rule against lying as well. Right, AI agents aligned to a particular moral theory might discover some of these surprising implications before we do, and they might discover them in practice rather than in the philosophy seminar room, which is where we prefer for them to come up. By contrast, aligning to common sense morality, you might end up with an agent that behaves more predictably, right? Making moral decisions like a regular human. It might be unpredictable in some edge cases, right? Where common sense arguably runs out, right? Would an AI aligned to common sense morality kill 1 person to save 1 million? I don't know. That's what we got into moral theory to try to answer hard questions like this. If we've just taught the agent to think about morality like we do, it might be as unsure as we are about what to do in a case like this. I need to let you go, so I'll just leave you with the thought, how bad would that be? How bad would it be if AI was as unsure about morally hard cases as we are? Okay. We've covered that. I will let you go to enjoy your Wednesdays. If you are interested in talking more about any of this, ethics in general, feel free to reach out, set up a meeting, we can talk more. Any questions now before we depart? Or I can stick around for a few minutes if folks want to talk to me offline. Okay, great. Well, take care.